In this video, I'm going to obtain the Thevenin equivalent circuit diagram while using the circuit diagram shown. So the first thing for obtaining the Thevenin equivalent circuit is to disconnect the load resistance and redraw the remainder of the circuit. So my load resistance is 240 ohms. So if I disconnect the load resistance and redraw the remainder of the circuit, I'll have something like this. So the circuit diagram above is a bit complex. So my 2 volts will move this way, and the 100 ohms is in series with the 470 and 560 ohms. So I want to find one resistor, R1, which will include the 100, 470 and 560 ohms. So the 100 is in series with the 470 and 560, while the 470 and 560 are parallel to each other. So solving this, I have, for parallel circuits, is the formula for the resistor. So I have my answer as 355.5 ohms as R1. So I've now reduced my circuit diagram to 2 resistors. So redoing it again, after solving for my R1, I'll now reduce the circuit diagram to this. So I have my R1 as 355.5 ohms, and I'll name this R2, which is 330 ohms. So the next thing will be to use the voltage divider concepts to calculate the voltage between the terminals A and B. So the voltage divider concept says that the voltage is also equal to the voltage of R2. The voltage in AB is also equal to the voltage in R2. This will be equal to R2 over R1 plus R2 times the EMF, which is 2 volts. So calculating this, I have 330 over 330 plus 355.53 times 2 volts. This gives me 0.963 volts. So this is also equal to the Thevenin voltage. Now that I have my V Thevenin as 0.963 volts, the third step is to short circuit the terminals of the voltage source to reduce it to 0. So I'll determine the resistance using the concept of looking back into the circuit. That is as seen from terminals AB. Now that I have my V Thevenin as 0.963 volts, the next step will be to find the R Thevenin, the resistance of the equivalent Thevenin circuit. So using the concept of looking back into the circuit, I can see that my 470 is in parallel with the 330 ohms. So I can make this into one resistor. So simplifying the circuit diagram, I'll have that 470 in parallel with the 330 ohms. So I'm still looking back into the circuit, and now my R Thevenin will be the 100 ohms is also in parallel with the 560 ohms. So my resistance for the equivalent circuit diagram is 100 in parallel with the 560 ohms plus 470 in parallel with the 330 ohms. Solving this, I have my R Thevenin as 278.72 ohms. Now I have my V Thevenin as 0.96 volts and my R Thevenin as 278.72 ohms. Now that I have the V Thevenin as 0.96 volts and the R Thevenin as 278.72 ohms, the next step will be to draw the Thevenin equivalent circuit, reconnect the load, and calculate the load current IL. So drawing the Thevenin equivalent circuit, I have something like this. So calculating the load current, I have that the load current is equal to V Thevenin over R Thevenin plus RL, which is the load resistance. So calculating this, I have my load current as 1.85 times 10 to the power negative 3 ampere. And that is how you solve for obtaining the Thevenin equivalent circuit. So if you like the video, please subscribe to my channel to keep up to date with such